infinity to infinity x of t into e power minus j omega t into dt. And inverse Fourier transform or synthesis equation is given by x of t is equal to 1 by 2 pi integration minus infinity to infinity x of j omega into e power j omega t into d omega. The transform x of j omega describes the signal x of t as a function of sinusoidal frequency omega and termed as the frequency domain representation for x of t. Pointwise convergence is guaranteed at all values of t except those corresponding to discontinuities if x of t satisfies the Dirichlet conditions for non-periodic signals. X of t is absolutely integrable. Integration of minus infinity to infinity mod of x of t into dt is less than infinity. And x of t has a finite number of local maxima, minima and discontinuities in any finite interval. The size of each discontinuity is finite. For example, find the Fourier transform of x of t is equal to e power minus at into u of t for a is greater than 0. Also plot magnitude and phase spectrum. Then x of j omega is equal to integration minus infinity to infinity e power minus at u of t e power minus j omega t into dt, which is equal to integration 0 to infinity, because it is given a is greater than 0. So integration 0 to infinity e power minus at into u of t into e power minus j omega t into dt, or integration 0 to infinity e power, taking minus common outside, will get minus a plus j omega t into dt. So e power minus a plus j omega into t divided by minus of a plus j omega, limit varies from 0 to infinity, which is equal to 1 by a plus j omega, which is equal to 1 by root of a square plus omega square angle minus tan inverse omega by a. Take a is equal to 1, then mod of x of j omega is equal to 1 divided by root of 1 plus omega square. Then the magnitude plot and phase plot for the given problem as shown in the figure. So initially magnitude plot increases from negative, that means when omega varies, at that time x of j omega increases and the maximum value is 1, amplitude is 1, once again it decreases. Similarly in phase plot, initially the plot decreases and when it reaches positive value of omega, we will get negative values of amplitude. Next problem, use the Fourier transform synthesis equation to determine the inverse ft or Fourier transform of x of j omega is equal to mod of x of j omega into e power j angle of x of j omega. where mod of x of j omega is equal to 2 into u of omega plus 3 minus u of omega minus 3. Angle of x of j omega given by minus 3 by 2 omega plus 5. Use the answer to determine the values of t, for which x of t is equal to 0. Then x of t is equal to synthesis equation 1 by 2 pi integration minus infinity to infinity x of j omega e power j omega t into d omega, or x of t is equal to 1 by 2 pi integration minus infinity to infinity 2 into u of omega plus 3 minus u of omega minus 3 into e power j minus 3 by 2 omega plus pi into e power j omega t into d omega, which is equal to 2 cancel 1 by pi into integration minus 3 to infinity e power j into minus 3 by 2 plus t into omega into e power j pi into d omega minus integration 3 to infinity e power j into minus 3 by 2 plus t into omega into e power j pi into d omega, which is equal to 1 by pi e power j minus 3 by 2 plus t into omega divided by j into minus 3 by 2 plus t, where limit varies from minus 3 to infinity, minus e power j into minus 3 by 2 plus t into omega divided by j into minus 3 by 2 plus t, where limit varies from 3 to infinity, which is equal to minus 2 divided by pi into t minus 3 by 2 into sine of 3 into t minus 3 by 2. Then x of t is equal to 0, which is equal to sine of 3 into t minus 3 by 2 is equal to 0. Then t is equal to k pi by 3 plus 3 by 2 for non-zero value of k. Then find the Fourier transform of constant a. Let x of t is equal to a by using analysis equation x of j omega is equal to integration minus infinity to infinity a into e power minus j omega t into dt. The integral does not converge. Strictly speaking, Fourier transform does not exist. For generalization, consider x of t is equal to a into e power sigma mod t, for sigma is greater than 0 and sigma tends to 0. Then analysis equation can be written as x of j omega is equal to minus infinity to 0 a into e power sigma t into e power minus j omega t into dt plus integration 0 to infinity a into e power minus sigma t into e power minus j omega t into dt, which is equal to integration minus infinity to 0 a into e power sigma t minus j omega t into dt plus integration 0 to infinity a into e power minus sigma t minus j omega t into dt, or integration minus infinity to 0 a into e power sigma minus j omega into t into dt plus integration 0 to infinity a into power minus sigma plus j omega into t into dt. Then x of j omega is equal to a into e power sigma minus j omega into t divided by sigma minus j omega, where limit varies from minus infinity to 0, minus e power minus sigma plus j omega into t divided by sigma plus j omega, where limit varies from 0 to infinity, which is equal to a into 1 divided by sigma minus j omega plus 1 divided by sigma plus j omega, which is equal to a into 2 sigma divided by sigma square plus omega square. As sigma tends to 0, x of j omega is equal to 0. Continuous time Fourier transform of x of t approaches 0 for omega not equal to 0. Area under the function x of j omega as sigma tends to 0. Then area is equal to a into integration of minus infinity to infinity 2 sigma divided by sigma square plus omega square into d omega, which is equal to a into 2 sigma divided by sigma tan inverse of omega by sigma. Limit varies from minus infinity to infinity. After simplification, we get the answer as 2 pi into 8. As limit sigma tends to 0, Fourier transform of the constant is a function that is 0 for omega not equal to 0 and has an area of 8. This exactly describes an impulse of strength A occurring at omega is equal to 0. That means Fourier transform of A will give you the value of A into 2 pi into delta omega. Similarly, Fourier transform of cos omega naught t and sin omega naught t can be derived as follows. Cos omega naught t is equal to e power j omega naught t plus e power minus j omega naught t divided by 2. That is equal to t into e power j omega naught t plus e power minus j omega naught t divided by 2, which is equal to half into t into e power j omega naught t plus t into e power minus j omega naught t, which is equal to 2 pi by 2 into delta of omega minus omega naught plus delta of omega plus omega naught, or t into cos of omega naught t is equal to pi into delta of omega minus omega naught plus delta of omega plus omega naught. So Fourier transform of basic signals are given in the below table. For delta of t signal, Fourier transform is 1, and for 1 constant 1, the Fourier transform is 2 pi delta of omega. Cos omega naught t, Fourier transform is pi into delta of omega minus omega naught plus delta of omega plus omega naught. And Fourier transform of sin omega naught t is equal to pi j into delta of omega plus omega naught minus delta of omega plus omega naught. Then sin t, Fourier transform is 2 by j omega, where omega not equal to 0 and 0 when omega is equal to 0. Then Fourier transform of u of t is 1 by j omega plus pi of delta of omega. Then Fourier transform of e power minus at into u of t, where a is greater than 0, the Fourier transform is 1 divided by a plus j omega. Similarly, Fourier transform of e power minus a of mod t is 2a divided by a square plus omega square. Then Fourier transform of x of t is equal to 1 when mod of t is less than or equal to a and 0 mod of t is greater than a. Then the Fourier transform is 2 into sin omega a divided by omega, which is equal to 2a into sin of omega a. Then the signal sin omega t divided by pi t, the Fourier transform is x of j omega is equal to 1 when mod of omega is less than equal to omega and 0 when mod of omega is greater than omega. Last, the signal summation k is equal to minus infinity to infinity ak into e power jk into omega naught of t, where omega naught is equal to 2 pi by t. The Fourier transform of the given signal is 2 pi into summation k is equal to minus infinity to infinity ak into delta of omega minus k omega naught.